Hello and welcome back to EUMETSAT for the third of our weekly roundup videos. During the course of last week, we were looking at the dynamics of the whole ocean and how we monitor that movement from space. And I'm joined this week by Remko, who is one of our satellite altimetry experts here at EUMETSAT. I'm actually sitting underneath one of the models of the spacecraft that you look after, the Jason spacecraft. So welcome to our weekly roundup video.
Thank you, Mark. Hello, everybody.
And let's turn now and have a look at some of the questions you've been asking during the course of the week. Tumelo was asking a question about the access to data. Remko, do you want to pick this one up?
Oh, yeah, sure, I can. In fact, Tumelo was worried that he needed to have an MSc or a PhD to download the data and even pay for it. Well, you don't have need an MSc, you don't need a PhD, you don't even have to pay. The Sentinel-3 data, Sentinel-1, Sentinel-2, all the Sentinel data will be free access. We are now, at this moment, still busy with the validation of the Sentinel-3 data, but by the end of the course, we will put online the information on how to get the data for free.
And so that'll be available to everybody?
For everybody. It doesn't require an MSc, it doesn't require a PhD.
Okay. What other questions did you see this week?
Tumelo actually asked a little bit more about, how do we validate the data? And then I can explain also a little bit about validation is.
Yeah, that'd be great.
In order to validate the data means that you're trying to figure out if what the satellite measures is what you want to measure. And if you can do that, you need to try to find something that will measure the same thing. Mm-hmm. For example, sea level. Sea level we know we can measure by tide gauges. So one of the ways we can do it is fly the satellite over a place where we have a tide gauge, offshore, hopefully. And then we compare what the tide gauge reads and what the satellite reads. For ocean color, we can actually have an installation in the sea that measures the color of the ocean independently. So that's the way that we can validate the data. Now he also asked if we can use Argo floats for validation, and yes, we do. Argo floats measure, for example, the temperature of the oceans down deep. It measures the expansion that we should see in sea level. But we also know that sea level will be also determined by how much mass, for example, in climate change, how much extra mass is added to the oceans. So the altimetry should see the combination of the extra mass and the expansion. The Argo floats will help us to measure the expansion. Another satellite called GRACE measures how much extra mass is in the ocean. Now the sum of the two should be similar to what the altimeter measures. And we talked 2 weeks ago about sea level rise. And in fact, we validate the sea level rise plot from altimetry together with the extra mass measured by GRACE and the extra expansion measured by Argo floats.
So you're kind of talking about two things there. One is doing new science to understand the system, and the other one is this validation thing of checking what we know and is the satellite data correct. How much of science is actually about the validation and the checking?
It's a lot of it actually, and in the beginning of these satellite missions, that's the main focus.
Right.
We want to make sure that what the satellite is measuring is what the user wants us to measure, so that then the scientists can continue, for example, look at ocean circulation and do their science with it. Put the data into the models without having to worry that the satellite is actually not measuring what it should.
Yeah.
So in the beginning of all the missions, we take half a year to make sure that all the products that we are generating are what they're supposed to be. That's the validation of the data sets.
And in the stage of Sentinel-3 right now, that's
where we are. That's exactly what we are at this stage.
There was also a question you saw about ice, which I think you wanted to pick up on.
Yeah, exactly. Edwin had the question about the icebergs. There was a bit in the videos about how we can find icebergs in SAR data and altimetry, and he wanted to have experts talk about it. Now, well, I'm a bit of an expert in altimetry, but there are a few experts out there that particularly focus on finding these icebergs. And in fact, they find a lot more funny things. They can actually find in the altimeter data ships. And one of the experts working for the French Oceanographic Institute, Yves, he has used all the altimeter data to basically figure out where the most ships are and to build up a statistical database of the most occupied ship tracks.
That's quite interesting.
Yeah.
And I guess this is building on the algorithms used for detecting the ice. Is it the same algorithm?
It is for the icebergs in this
Yeah,
case,
yeah.
yes. Because ships and icebergs, they have a similar signal, so it's difficult actually to distinguish them. But of course, we know that ships are generally not hanging up much between the ice, and the ice is not hanging up much where the ships are.
Yeah.
So in that case, there is a way to separate the two. So these kind of applications of something that was totally not expected
Yeah.
are actually quite interesting, and we keep on learning. We keep on seeing things in data that we have been using for a very long time, but also the instruments are improving so that we can actually do that. Data rates, for example, now we can get from the satellite way more information than we used to.
There's a couple of other questions I wanted to pick up on the forums that we saw this week. There was one question from Agnes who was asking, can you have a geostationary satellite over the poles? And one of the issues with that is you can't actually put a geostationary satellite over the poles. You can have what's called a Molyneux orbit or a highly elliptical orbit, where you have a satellite that goes quite close to the Earth as it goes over, say, the South Pole, and very high and effectively kind of quasi-geostationary as it goes over the North Pole and then down, or the same going over the North Pole very quickly and over the South Pole slowly. But the issue with the geostationary orbit is the Earth actually rotates round and the satellite orbit is taking 24 hours. So it's only effectively over one point in the Earth, but both the satellite and the Earth are moving. You can't do the same over the poles. There was also a question that we wanted to pick up from John and Pedro and a couple of others who were asking about the global ocean circulation. So what's it all driven by? Is the Gulf Stream part of the thermohaline circulation? Is it driven by saltiness? What's the relationship between the saltiness of the water, the density of the water, and temperature of the water? So the Gulf Stream is an example of a current that's wind driven. So it's the surface winds that force that current to develop and evolve. The large scale circulations that you see within the ocean, they're driven mainly by the temperature and then the saltiness. And it's a combination of the whole thing. So there's only one ocean, it's one dynamical system. You've got the cold water sinking. Now, if that cold water is salty, so if some of the brine or the salt in the ice mass has come into the water, then that water is saltier and so it sinks faster. If you've got ice melt generating more fresh water, then it sinks slower. That all sinks down in mainly the polar regions and will then mix, become slightly warmer and then upwell elsewhere in the ocean system. And that whole dynamical system, the thermohaline circulation, is incredibly complex, and it's really important we understand it so that we can properly understand climate change. I've really hoped you've enjoyed the week, and we've really enjoyed watching your responses to the weekly task. Next week we're going to look more at the biology of the oceans and the living oceans, getting much more into the skin of the ocean colour data. And we hope you to continue to enjoy the course, and we'll see you next week.